show you the 2500 double-acting piston metering machine. It's comprised of a B metering cylinder, an A metering cylinder, an air drive assist cylinder, and this model has a pot life or anti-gel timer on it. What's interesting about this machine and the 2500 in general is all of this metering is tied together on a single piston rod that runs across the entire machine. So if the A piston moves, then the B piston has to move, and you don't have the lead lag effect you get with systems that do not have one continuous rod. The system's designed such that the OD of these cylinders is the same, which allows us to use similar hardware throughout the system to keep costs down. And we change the inside diameter of the cylinders to achieve the ratio. So the way we achieve the metering on this system is to have the volume of the metering cylinders would be the same as the volume ratio of the adhesive. So for instance, if this was a 2-to-1 system, the volume of the A side would be twice the volume of the B side. Now we maintain the same outside diameter, which allows us to use the same hardware throughout on the outside. Pistons are typically slide in here, and as I mentioned earlier, this shaft is connected here, so the two pistons are joined by a single shaft. And these pistons happen to have O-ring seals, a double O-ring seal, to prevent bypassing the cylinder. So at maintenance time, it's simple. The replacement parts are simply 2 O-rings in either side. Another important feature of the 2500 cylinders, as well as some of the other equipment Ashby Cross manufactures, is once these cylinders have been cut and honed to the proper ratio, a hard coat finish is applied, and that's really important when you're processing abrasive or heavily filled adhesives. So what you end up doing is elongating the life of the cylinders by adding the hard coating. The Ashby Cross 2500 double acting will ship with a air regulator where house air is plugged in. We'll have a dryer or filter on it. Then the main air in is here. These bleed tubes are used when the system is first started, or if the material runs dry in the system. These bleed tubes are used to bleed air from the system, from the tanks or the pumps, up through here. It's a one-step process that once the system's bled, it doesn't have to be bled again. The pot life timer is adjustable. What that does is it prevents material curing in the static mixture. So if you have a 2 or 3 minute pot life or a 10-minute pot life, you would set this timer to maybe half the pot life or 3/4 the pot life of the material, and what the machine will do is it'll purge the mixer of 6, 8, 10 cc's of material, and it keeps the mixer alive. On the dispense side of things, you have, this could be stationary, that's generally mounted here or somewhere on the bench, or in this instance we have a pistol grip dispense gun. The static mixer attaches to the nozzle here, and this has swivels on it, which makes it a little easier to apply the adhesive. This is the back side of the 2500 double acting. It shows the continuous shaft, connects the A and the B metering cylinders. These hoses would be from the tanks or from the pumps. The material is kept separate, the A side and the B side, and they feed into rotary valves on either side. And those two rotary valves are connected by, or actuated by, this air-operated actuator, and it turns the rotary valves as needed depending on the cycle of the pistons. So, for instance, the material is flowing into the rotary valve, and this is a double-acting system. Let's say material then from the tanks is feeding in to this end of the catalyst cylinder, and at the same time the resin is feeding in to this end of the resin cylinder. So the pressure is driving material into this end. As the piston moves through the cylinder, metered material then is coming out to the dispense head. So what these pistons basically do is shuttle back and forth. Now once the piston reaches its limit here, it trips an air switch. The actuator rotates the valve 90 degrees, so then the feed material coming in is directed to this hose, entering the cylinder here, driving material that way, pumping metered material out through the head. Okay, so let's take a look at a single rotary valve. Now these valves work in unison, but let's see how one operates. Material is fed in under pressure from the tanks or the pumps or the drums. It enters here. This rotary valve, let's say in this operation, is connecting the input to here. Material flows down into the cylinder, driving the piston in this direction. At the same time, now the metered material is coming out through the valve to the dispense head. The piston reaches its limit, it trips an air switch, this valve rotates 90 degrees, now the input feed is coming here and into this end of the cylinder, driving the piston in the opposite direction. Now metered material is coming out the dispense head. So this rotates 90 degrees back and forth, causing the pistons to shuttle back and forth, and that's how we get the metered material, and that's how we get continuous flow out of this machine. There is no recharge cycle. This one continuous shaft will travel in and out of the cylinder blocks in 4 places. So at the end of each cylinder block there's a wet cup reservoir, and the wet cup reservoir has a series of chevron packings and a couple of O-rings. And what that does is, number one, keeps the material inside the cylinder, and the O-rings wipe the shaft clean. In addition to that, we have a small area here where we fill these reservoirs with an inert oil, which help keep the shaft lubricated and help keep the material inside the cylinder. Because if material such as a isocyanate gets on the shaft and dries out in the air, then as it moves back and forth in the seal area, it deteriorates the seals and you end up with a leak. So the wet cup reservoirs are an important part of the process machine as built by Ashby Cross. Each place where the shaft leaves the cylinder block area, there is this wet cup reservoir with seals in it, and also an area where you can fill with iso oil, which keeps the shaft packings lubricated, as well as the shaft keeps the material, the adhesive, inside the cylinder. We've discussed the metering section, the dispense head, the cylinders, gel timers. This could be referred to as the feed or the reservoir section. This is how the adhesive is fed into the 2500 double acting. This happens to be heavily filled material which tends to settle over time, and it's being supplied in 55-gallon drums. So air-powered pump drives the material to the metering section. At the same time, there's an air-driven agitator which circulates in the drum and keeps the fillers in suspension, so you have a decent product. It's pneumatic air cylinder. You apply air here and the entire assembly lifts so you can replace the drum, and then you lower the entire assembly. So this is a 55-gallon drum feed. For heavily filled or high-paced materials, this is 2500 double acting. It'll be fed out of 55-gallon drums with ram pumps. The purpose of the ram pump is to drive the paste with this follower plate into the pump and then into the 2500 double acting. Here's an example of the 2500 double acting that's got a number of features which will show you what a potting machine is generally constructed. There's a 5-gallon Part B tank with sight tube for finding level. There's a vacuum pump on board which is used to degas the material, so we have air-free dispensing at the dispense head. There's a 10-gallon Part A tank, and you can see it has an electronic low level which sends an alarm when the level hits about a gallon left in the tank. For shot size control, we can add optional linear encoder which is attached to the piston shaft, and the encoder watches the piston shaft sends a signal up to the digital controller so you have accurate, repeatable shots. The 10-gallon Part A or resin tank is heated and insulated to reduce the viscosity to make it easier to process through the machine. When we do that, we also add an agitator so we can stir the heat from the bottom into the rest of the tank. And also there's fillers in here. When it's heated, the fillers tend to settle, so we add the agitator to keep the fillers in suspension. The heating is done in the bottom of the tank with a cow rod type heater that's embedded in a heat compound. There's a thermocouple in there that senses temperature and proportionally controls it through the control panel.